Good day everyone. In this video, we're going to discuss about converting linear system into coefficient matrix, augmented matrix, and linear combinations. So let us have our first example. Let us have 2x plus 5y equals 9. And then another one is 3x minus 7y equals 4. This is our linear system with linear equations 2x plus 5y equals 9 and 3x minus 7y equals 4. Let us have first the coefficient matrix. For the coefficient matrix, what we're going to do is to just copy all the coefficients of x and y to form the matrix. So, in our equation 1, the value of x is, or the numerical coefficient of x is 2. The numerical coefficient of y is 5. For our second equation, the numerical coefficient of x is 3, while negative 7 for y. And that is our coefficient matrix for the first linear system. And now let's proceed to the augmented matrix. Okay, so for the augmented matrix, what we're going to do is to just add the value of b for our matrix. So let's just copy the value of x and y, and then we have to mirror the value of b. Then we have 2, 5, and 9. Also, we have 3, negative 7, and 4. And that would be our augmented matrix for our first example. And now let's have the linear combinations. Linear combinations. So we'll have, first let us take the literal coefficient. So we have x followed by its numerical coefficients 2 and 3, then plus the second variable, which is y, followed by its numerical coefficients, which are 3 and negative 7, and we're going to equate it to the right hand side, which is 9 and 4. So this is how we're going to convert the linear system into coefficient matrix, augmented matrix, and linear combinations. So let us have our second example. Let us have here 3x minus 2y plus 4z equals 10. And then for the second equation, let's have 5x plus 6y equals 9. And then for the third, let's have 7z minus x equals 8. So this one is different from our first example, since in this example we have three variables for three linear equations. So let us take its coefficient matrix. So we'll have the numerical coefficient of x is 3, 5, and then for the third linear equation, it is negative 1. It is important we have to locate the placement of each of the variables. So let's have, for y we have negative 2, 6, and for the third linear equation, we do not have a value of y, so it will be 0. And for z, we'll have 4. In the second equation, we do not have the numerical coefficient, so we have 0 and then 7. And that is the coefficient matrix of our linear system. Then for the augmented matrix, we're just going to have, again, the numerical coefficients for x, y, and z. Negative 3, 5, and 1. Negative 2, 6, and 0. And then 4, 0, and 7. And then we have to mirror the right hand side. We have 10, 9, and 8. And that would be our augmented matrix for our linear system. And lastly, for our linear combinations, we have here the variable x. Let us have its numerical coefficients. We have 3, 5, and negative 1. Followed by plus y. We have here negative 2, 6, and 0. And lastly for z, we have 4, 0, and 7. And then let's equate it to the right hand side, which is 10, 9, and 8. So that is the way on how we're going to convert linear system into coefficient matrix, augmented matrix, and linear combinations. I do hope that you've learned something from this video. Thank you for watching.